in this example for integration by parts, I'm going to use what I normally call the 1/2 trick or the addition trick to help solve an integration by parts in a way that you may not think to do it unless you were taught how to do it. Because I certainly wasn't clever enough to figure this out before I was taught how to do it. But hey, maybe you're smarter than me. Wouldn't take much. So let's try to find an integral e to the x sine of x dx. Now for this particular problem, it actually doesn't matter which one you use for u and dv, which is kind of nice. So just as long as you don't pick u to be like the whole thing. If you do, I don't think it's going to work. All right, so I'm going to say u is equal to sine of x and dv is e to the x dx. The reason being is I like to think of trig functions in terms of derivatives. I'd rather not think of them in terms of antiderivatives. It's personal preference. So du is cosine of x dx and v is e to the x. So by using the formula here, we have uv, so that's e to the x sine of x minus the integral of v du e to the x cosine of x dx. Okay, so we end up with an integral that looks a lot like this, except we have a cosine function instead of a sine function. So what we're going to do is we're going to apply integration by parts to this piece. We're going to say, okay, u is now cosine of x. So I'm actually going to do something even a little more trickier. I'm going to turn this into a plus, and I'm going to pull the negative inside. And that's going to make our lives a little easier. So instead of u being cosine of x, I'm going to let u be negative cosine of x. And dv is going to be e to the x dx. So du is going to be a positive sine of x dx, and v is e to the x. So now I have this whole thing. I have e to the x sine of x dx equals e to the x sine of x plus, so I have this integral. So this is my u dv. So I have to then say that's equal to uv, so minus e to the x cosine of x. So uv, again, minus v du. Okay, so I'm going to rewrite this for a second. And say, okay, well that's e to the x minus e to the... Well, crud, right? We're back where we started. We started with e to the x sine of x dx. Now we got e to the sine of x dx. How do we solve this? This is kind of annoying, right? Well, what you find is that as long as you have something on the same side of the same type of quantity, just use some algebra. What? Use some algebra. We're going to say, okay, well, what if I add those? Huh. can I do that? Well, yes, I actually can. But we have to be careful. The way we have to be careful is that this integral and this integral may not actually have the same arbitrary constant. This one might have C1, this one might have C2 because of the way it goes. So what we end up with is, though these will cancel, but it won't become 0. It'll actually become your plus C, because the constants differ. There's still some sort of differing constant that's there that you have to keep track of. So instead of one of these, I have two of these. But I don't want two of these. I want one of these. I only want to start with one. So if I divide both sides by 2, and I'm going to factor out an e to the x here. And you might say, well, I don't have a c divided by 2. You could write c divided by 2, but generally speaking, since it's arbitrary, something arbitrary divided by 2 is also arbitrary, so it doesn't matter. It's just some sort of, dangling junk box term that we might have to solve for if we were doing an initial value problem or a differential equation or something like that. So this is how you do that. That's that addition trick, as I tend to call it, or 1/2 trick. I don't know if it's a trick or if it's a method. I don't know. But that, if you do something like that and you end up generating the same integral you started with, then there's two things you might have done. One, you did integration by parts twice and you swapped your u and v. Then you'll end up getting back to where you started. Don't do that. The other one is, if you end up with like a plus here and a minus over there, add it over. It may not always be 1/2. It sometimes comes out that this is like a 1/9 or a 2/17 or something because of the way it works. When you add it over, you'll just end up with some amount here, and you'll divide by that amount.